Okay, here we go. Graphs, tables, and linear functions. Let's do a quick review of functions. A function is a relationship for which each input x has only one output y. This is a function. You have your x inputs and you have your y outputs, and you see that for each x there is one and only one y. This is not a function. And let's look at why. You do have your x inputs, but you notice that there's two of the same x value, and they correspond to two different y values. So that is not a function. A linear function is any function whose graph is a straight line that can be written in the form y equals mx plus b, where m is the slope and b is the y-intercept. It is one in which there may be one or two variables, but no exponents. X or y cannot be in the denominator, and there are no radicals. Let's look at some examples of linear functions. Y equals 2x plus 4, negative y equals 4x minus 2, y equals x over 5 plus 5. And in the case of nonlinear functions, this may be a function, but it's not a linear function. We have an exponent here. We have x and y being multiplied together here, and here we see a radical. So although these may be functions, they are not linear functions. Let's identify a linear function by analyzing a table of values. There must be a constant rate of change between the x values and a constant rate of change between the y values. That constant rate of change does not have to be the same for the x values and the y values. The table on the left shows linear function. You see that the rate of change for the x values is the same, and the rate of change for the y values is the same. Over on the right, we have a different rate of change for the y values. So this may be a function. It may be a relation that's not a function, but it's definitely a nonlinear function. It's nonlinear because the rate of change between the y values is not the same. We can identify a linear function by analyzing a graph. First thing we can look for is it a straight line? Well, it definitely passes that test. Now we can plot a few points that are on that line. We have plotted 4 points on this line. And you could make an XY table of the values for these points and check that the points pass the rate of change test, just like we did in the last slide. We looked at the tables of values. Once we have the x and y values, we can use the slope formula to find the slope of the line. In this case, when we do the mathematics, we find out that the slope is equal to 1. We also see that the y-intercept is at 3, 0, 3. So our linear function is written as y equals x plus 3. Is this line a linear function? Well, we can make a table of a few xy points on the line, which we've done here. And we notice that it does pass the rate of change test because you see that the rate of change on the x values is 1.5 and the rate of change between the y value, each of the y values is 0. So when we find the y-intercept being 1.5 and we can calculate the slope, we find that y equals 1.5. This is a linear function. Okay, well that ends this very brief video on graphs, tables, and linear functions. Enjoy the activity.